Hello. Thanks for the warm welcome, Remy. So, as I'll mention a bit later in the talk, I've been coming to FFConf for quite a while now. And I think I always dreamed of giving a talk here, but I never thought it would actually happen. But here I am today. This journey is from when I was 6 to now when I'm 16, and that spans 10 years, and it turns out quite a lot can happen in 10 years, and it's pretty hard to condense that all down into a 30-minute talk, but I've done my best, and some things might be omitted for brevity. So, our story starts when a singularity exploded, expelling billions of tons of matter at the speed of light and creating the universe, an event commonly known as the Big Bang. After that, about 13.7 billion years happened, including dinosaurs, an industrial revolution, and the invention of sliced bread. And then in December 2008, I was born. For a few years, not much interesting really happened, but then when I was 6 years old, I asked my dad to teach me how to code. So something that I think is quite important to this story is the fact that for basically my whole life, I've been home educated. So that means a few things. One of them is that I basically have to learn everything from my parents until at least I'm old enough to use the internet to look stuff up for myself. So the skills I decide to learn need to be things that my parents already know. So that was part of the reason I chose programming. But it also means I have a lot more freedom to focus on whatever I want to do, and I'm not constrained by a predefined school curriculum. And I have a lot more free time than if I had to go to school 5 days a week. So at the time, I was enjoying playing a video game called Little Alchemy. This is what it looks like. As you can see, you start with 4 elements: water, fire, earth, and air. And then you can combine 2 of them to make something new. And once you have that new thing, you can combine it again, and you can keep on going ad nauseum. So I like this game, but some of the combinations, or lack thereof, were just a bit unsatisfying to me. So I decided to make my own. Here's my version. It's basically the same thing, but with a little bit of a worse UI. Design was never really one of my strong suits. And yeah, so it's basically the same app, but the great thing about this is that I control all the combinations and I can customize it however I want. So this was really my first ever programming project. You can actually still play this. It's online at Potions 10 years later. And I guess it was my first project in maybe less of a conventional way than, say, an adult learning to code, because I was only 6 years old and I couldn't really learn the full extent of the code at the time. So my dad wrote the code, but we talked through it together and he explained to me what the different bits did. I'm not sure if it all sunk in at the time, but I definitely took away some useful skills from this. So for example, the pattern of data-driven development. So here is a piece of code from the file that defines all of the combinations in the game, and as you can see, it's just an array where each element contains the 2 ingredients and what they combine to become. And this is a really useful pattern that I used in a lot of later projects. It also helped me learn some basic computer skills as a young kid, like how to save a file, how to navigate between windows, simple shell commands like lscd, or simple git. But my commit messages weren't that good at the time. So after I'd made my first project, my dad decided to start some programming classes for me and kids of my age and older. And through these, I was able to solidify and improve my programming skills. And part of that was through teaching and helping the other kids. So I've always been quite interested in maths and logic, and so programming came quite naturally to me. But sometimes the other kids would have problems and I would be able to help them. And teaching, I've always found, is a really good way to learn something better yourself, because in order to be able to explain something to someone, you need to understand it really well. And at the same time, different people think in different ways, so you often end up adapting your explanation in a way that makes it easier to understand for the person you're teaching, which forces you to think about the problem in a different way than you would have previously. So, in 2017, when I was 8 years old, I came to FFConf for the first time. That photo is actually from 2018. I couldn't find one from 2017. I'm probably in there somewhere, but I couldn't find myself. Maybe I was too short to be seen. I don't know how many of the talks I really understood that first time. I was still learning to code myself, let alone understanding other people's code. But clearly I enjoyed myself enough to come back some 5 times afterwards. I also didn't stay for the whole conference. At lunchtime, my mum came and picked me up and took me home, which is, I didn't really notice any of the other attendees' mothers coming to pick them up. At the same time, I also went to Async, which has been mentioned. So it's a monthly programming meetup that my dad started back at the same time as FFConf in 2009, and every month someone comes to give a talk, but once a year before, on the night before FFConf, they have a special show and tell where people can come and talk for 5 minutes about something interesting they've been making. Did anyone here actually go to Async last night? Okay, yeah, a decent number of people. I unfortunately wasn't able to make it because I was at the speaker's dinner, but but next year I'll definitely be there because it's lots of fun. Anyway, I talked about potions, which was the only project I'd really made at the time. You can find out more on their website if you are interested in attending. I couldn't unfortunately find a photo of me presenting for the very first time. This was the only one I could find, really. It's not a very good quality image. There's me in the corner there. The project I'm presenting there is this game. It's a 2D survival game made when I was about 10 years old. It's pretty simple. Your objective is to jump over the slime, get to the dagger in the tree, and then kill it before it kills you. Once again, like potions, it wasn't really a particularly original or impressive creation, but it definitely helped me learn a lot of useful things like SVG, input detection, collisions, and lots of other stuff. So, one of my favorite video games of all time is Minecraft. And one day, I decided to look into a specific feature of Minecraft called commands. So a Minecraft command is a bit like a shell command. You type in some magic characters into the prompt, and then something happens. So in this case, it's the teleport command, which lets you teleport yourself or any other creature to a different location. And I went down a bit of a rabbit hole learning about all these different commands you could do. And I discovered something called data packs. So a Minecraft data pack is a bit like a shell script. You can write a bunch of commands into a file, and then you can execute that file in one go rather than having to run each command manually. And with data packs, you can also set up a trigger so that when something happens in the Minecraft world, it will run your script, and you can create behavior with that. It's designed for things like adding new equipment or changing a recipe, but they're Turing complete, so you can really do whatever you want with them. And at the same time, there's this weird mix between low and high level languages. On the one hand, all variables are global, there's no scope, and functions don't have arguments or return values. So if you want to call a function with arguments, you need to just put that data in some predefined global location. Then the function reads from that location, processes it, and puts it back somewhere else, which you can then take as the return value. On the other hand, though, it's like a virtual machine in a virtual machine in a virtual machine. So it's super abstracted from any concept of an actual device running the code. And this creates quite an interesting dynamic. You need to solve problems in different ways than you would in any other programming language because it's a completely different paradigm of language. We heard about esoteric programming languages in the previous talk, and you could argue that data packs are an esoteric programming language. And for some reason, this just really caught my interest. I really liked the way that you had to think outside of the box and come up with weird, hacky workarounds to the limitations you have, often involving the fact that the code is running inside a literal three-dimensional virtual world. And I got really interested in data packs in a way that web development hadn't really caught my interest before. So after I had been working on them for a little while, I decided to start a YouTube channel. Originally, this was to share one of my data packs. There's the thumbnail of my first video. It was showcasing various features from a data pack that I'd made. But later, I expanded it and did various different types of videos, such as tutorials on tricks that I had figured out and other interesting things that I thought of. I also needed a name for myself when I created my account. I could have used my real name, but internet safety tells us not to do that, and also it wouldn't really be cool enough for a Minecraft datapack YouTube channel. So I thought for a while, and I came up with Gears. So it's short, memorable, easy to spell, and it fits with the vibe of programming languages, machines, etc. And that name has really stuck with me since then. If you look me up before the talk, or if you do so afterwards, I still use it for all my online accounts, so that's where the name came from. Making YouTube videos also really helped with my public speaking. Up until that point, I was quite nervous speaking in front of an audience, and you can really hear that in my first video, but over time, I gained confidence, and that really helped when it came to this talk. I also participated several times in a datapack jam, which is like a game jam. It's a competition where you get given a theme and you have a short amount of time to create a datapack relating to that theme, but you can interpret it however you want. So for example, one time the theme was ancient technology. So me and a friend of mine made a little robot which you could program to control around your Minecraft world using a custom scripting language that we'd made. So these competitions, I think, really brought out the best programmer in me. The strict deadline gave me lots of motivation to work on the features and come up with a solution within the time limit, although it was at the cost of some of my sanity and sleep. Me and that same friend later started a podcast where we talked about various datapack-related topics. It's now on indefinite hiatus while we're studying, but it was fun while it lasted. And me and him also gave a talk at an online in-game datapack conference, which was lots of fun as well. All this is to say that learning Minecraft datapacks doesn't necessarily help me get a job at a tech company. None of them hire datapack creators, although it turns out some people are willing to pay for you to make them a Minecraft datapack, so I did make a bit of money from that. I still got a lot of value out of it. I mean, first of all, just having to solve lots of different problems definitely helped with my problem solving and logical ability. But also, I was able to find a community of people who shared the same niche interests with me. and I was able to connect with them through that shared interest, which is something that I don't think I'd really done before. So after I had learned Minecraft data packs, I decided I wanted to learn more languages. Until that point, I'd really only known JavaScript. That was what I learned when I started, and that's what I used for all my projects since then. So I did. I learned lots of new languages. And some people would say this is really bad. You're not supposed to learn lots of languages really quickly because you just end up with a surface-level understanding of each one, and you become a jack of all trades, master of none. But that wasn't really my experience. While, yes, it was the case that most of the languages I didn't go that deep into, and I mostly just learned the basics of the language without creating many serious projects, I do think that I got quite a lot of value out of each language that I learned. If you know a particular programming language, you think of all of the problems in terms of the paradigms of that language. So a Java developer thinks of everything in terms of classes. A Haskell developer thinks in terms of functions and monads. But a Java developer who knows Haskell might still come up with a largely class-based solution due to the nature of Java, but they can integrate some of the tricks and patterns they learned from Haskell to create a solution that they wouldn't otherwise be able to come up with had they only known Java in the first place. So learning new languages, even if you don't end up using them much, still gives you a new perspective on the problems which you otherwise would have had a one-dimensional view on. And when I was learning these new languages, I realized something. None of them were perfect. All of the languages had some feature that was missing, or that I didn't like, or that didn't work how I wanted it to. I think this is quite a common experience. The creator of C++ once said there's only two types of languages, the ones that everyone complains about and the ones that nobody uses. But nevertheless, I had an idea. What if I create my own programming language? That way, I can design it to be my perfect, ideal language, and I won't have any complaints. But I had a problem. I didn't know how. So I was stuck until I found a YouTube series about making parser combinators. Parser combinators are a pattern taken from, I believe, Haskell, where you define a set of parsers, which are small programs that understand some piece of text, like an identifier or a number or white space. And then you combine them to create a more complex program that understands more complex forms of text. So I thought that was pretty neat, and I decided to use it to make a language. If you're wondering about the scripting language in the data pack that I mentioned earlier, this talk isn't in perfect chronological order, unfortunately, because I had to group things by subject, so this did actually come before that. Anyway, this is my first language. I called it language because I didn't have any better ideas. So this is a basic program in it. It's pretty simple, familiar syntax. You're defining a function, calling it, and then writing some stuff to the console. And I managed to get to a point where this could parse and run. But I very quickly realized that parser combinators aren't a very good way to write programming languages. And part of the reason for that is the error messages. Parser combinators are a bit like regular expressions. You start at the beginning of the text, and it tries to parse through and understand the content. And if it gets to the end, then great, you're done, you can move on. But if it fails at any point, it backtracks and tries something else. And it'll keep on doing that until it either successfully parses the whole file or gets stuck at a point. So let's take an example. Here I have an if statement, but I've forgotten the closing bracket after the condition. So the parser will go through, it will parse if bracket condition, and then it will run into the missing bracket, and it will say, oh, there's an error here. This isn't a valid if statement, it's not got a closing bracket. So it backtracks to the beginning and tries something else, like a while loop. Obviously, this isn't a while loop, so that will fail as well, and it will keep on going until it fails all its options and return a generic, "I don't know what this is" error message, because by the time you've backtracked and tried all your options, you've lost all the context about where the original error was. And it just wasn't working, so I scrapped that project, and I was back to square one. Until I found another YouTube series about building a custom scripting language. This one taught a much more traditional approach of using Alexa, which turns source code into a string of, or a sequence of tokens. Each one has some kind of meaning, like an identifier, a keyword, an operator. And then a recursive descent parser, which is an algorithm that iterates through the tokens and turns them into a tree, which is easier to understand. Unfortunately, the series was a bit incomplete, but I managed to take what I'd learned and create my second language. This one's called test language. It looks exactly like JavaScript because this one wasn't meant to be my ideal language. As the name suggests, it was a test language to see as a proof of concept how far I could get with what I learned, and it turned out I could get pretty far. Classes were the last thing I implemented before moving on to tackle the final boss, which was designing my ideal programming language. So I thought a lot about what kind of features I wanted in my language, and I wrote it down. There's the design document for my ideal language. It's all on my GitHub if you're interested in reading it. I called it Libra, after the zodiac sign for scales, because I wanted it to be a balance between all the best features of the programming languages that I knew. So, for example, I really like statically typed programming languages because they make it impossible to do certain mistakes that are really common, like misspelling a variable name. And it also makes the program easier to understand because you can understand what type of data is stored in each variable. I also like the Go style, the interfaces in the Go programming language. The fact that you can define an interface and any object which implements the required methods automatically implements the interface instead of the more explicit style that is used in, for example, Java or Rust. And I also liked algebraic data types, which is, I won't explain it really now, it's what a lot of functional programming languages use, and it's what Rust uses, and it's just a really nice way of representing information. By the way, I forgot to mention the previous two languages were both implemented in JavaScript, but this one I wrote in Go because that was my favorite language at the time. So I started implementing this after I had designed it, but it turned out that a lot of the features that looked really good on paper actually were a lot harder to implement when it came to writing the actual compiler. I never really ended up finishing this project because I got sidetracked by something else, which we'll talk about in a little while. So 2 years ago, I was at the after party for FFConf, and I was talking to someone who was telling me about how they had been contributing to some web browsers. And they suggested that I do the same thing. It would give me experience writing large code bases, contributing to open source, and also give me something to put on my resume if I wanted to get a job in software development later. So I took them up on their advice, and I found the source code for WebKit, which is the technology behind Safari and Chrome, I think. So I cloned it to my machine, and after about an hour and a half, yeah, that's literally how long it takes to clone WebKit, I finally had all the source code downloaded, and I took a look. So WebKit is a massive project. It's got millions of lines of code, hundreds of files, and also it's written in C++, which is a language that I know, but I don't really have any experience writing actual code in it. And because of all these things, I never really got started. I fell at the first hurdle and never ended up contributing anything. But I still had the idea of contributing to open source in the back of my head. At the time, I was learning Rust. Wait a second, Rust? Well, it's written in Rust, which I know, and it's also a compiler, which is an architecture I'm much more familiar with than, say, a web browser, because I've been writing one for the past year or however long, whereas a web browser, I really wouldn't know where to start. And I'd been wanting for a while to look at a real-world compiler codebase to understand how it was architectured, because my compiler was starting to get quite big and difficult to work with, and I wanted to see how a real-world project dealt with that. So I cloned the repository and found an issue marked easy. It turned out not to be that easy, because it took me quite a long time to figure out my way around the code base and understand what I needed to change in order to solve the issue. But after a lot of hard work and head scratching, I eventually came up with a solution, and I opened a pull request. And after some back and forth feedback, it finally got merged. But at the end of the process, I didn't really feel satisfied with my contribution. I mostly felt relieved that it was over. The whole... That was meant to be serious, not funny. The whole process was quite stressful to me, trying to understand how this massive code base worked, getting my code scrutinized and having to change it again and again. And I just didn't really enjoy the process, so I stopped contributing. And then in March of 2024, last year, I came across a new language called Gleam. That was when it went to version 1, at which point it gained quite a lot of popularity. There were lots of articles and videos made about it, and I stumbled across it one day. For anyone who doesn't know, Gleam is a functional, statically typed programming language that compiles to both Erlang and JavaScript, so you can use it to build front-end web applications as well as fault-tolerant, highly concurrent backends. Also, unlike a lot of functional programming languages, it has really nice, familiar syntax to anyone who's written, for example, JavaScript, which is what I knew. And also, all the documentation, rather than using a lot of the jargon that gatekeeps functional programming language, like monads, functors, currying, whatever, the documentation doesn't use any of that, and it explains everything in really simple terms. It's also an extremely small language. Like, that's basically all the syntax you need to know to write a Gleam program. You don't need to read that now, but the point is, it's really sleekly designed, and you can learn it in an afternoon, really. And as well as that, the tooling is really good. It's got a great language server, formatter, and it's all integrated into one binary, so you can install it really easily. So that sounds great, but at the time, I was quite happy with Rust, and I didn't really feel like learning and switching to a new language. I'd already gone through that phase earlier. So I mostly dismissed and forgot about Gleam, until I had an idea. Gleam must have a compiler, and also it's a relatively new project, so theoretically the compiler would be a lot smaller than something more mature like Rust. And I took a look at the Git repository, and look at that, it's written in Rust, which I know. So I decided to take a crack at contributing. So I found a good first issue, and cloned the repository, yada, yada, yada. And this time, it was a lot easier for me to come up with a solution. Gleam is a much smaller code base than Rust. It's also really well written and pretty well documented. So I didn't find it that tricky to find my way around and come up with a solution. As well as that, Louis, who is the creator and maintainer of Gleam, is just a really nice guy, so the review process went super smoothly, and afterwards I'd found that I'd really enjoyed it. So at that point, I decided to keep contributing. I'd only really scratched the surface of the compiler, and I wanted to dig deeper to understand how it really worked, so I could take that and use it in my own compiler. And I really kind of got a bit addicted to contributing. I worked on more issues, made more pull requests. It was a bit weird though, because I wasn't using the Gleam language, yet I was contributing a lot to the compiler. But I didn't really mind because I was having lots of fun. And also the Gleam community is really nice. It's one of the most friendly and welcoming communities I've found on the internet, so that definitely helped me enjoy the whole process. When I did later start using Gleam, I really liked it. I think it's a really well-designed language. All the features are very carefully considered, and it leads to quite a coherent, simple language that you can still do all the stuff you would do in any other language. But maybe I'm biased. Using Gleam also helped me find lots of bugs in the code and gave me ideas for features to add and change. So I definitely recommend using the software that you're making. And then one day in October last year, I got a message from Louis, and he asked me if I wanted to join the core team. It was an unpaid position at the time, but I thought it would be a good experience, and so I accepted. And I haven't regretted my decision. I just really enjoy being part of this community and working on this project with other like-minded people. And actually, earlier this year, I started a GitHub sponsors where people can donate to me to support my work on the compiler, and Louis was kind enough to sponsor me, so I guess it is a paid position now. And that really brings me to 2 months ago when Remy emailed me asking me if I wanted to give a talk here. Like I said at the beginning, I've always dreamed of giving a talk at FFConf since I started coming. So I accepted immediately, and here we are today. I'm giving another talk at Gleam Gathering, which is the first ever Gleam conference in Bristol next year. So the website's there if you're interested in that. And that's really it. If you want to join the Gleam code cult, gleam.run is the website. You can find more about that. My website is Gears Code. If you want to check out any of my projects that I mentioned this talk, they're all on my GitHub, which is linked from my website. And I'm at Gears Code on Blue Sky, so you can follow me there. And I guess the moral of my story is that you should start by making something useless that you enjoy, like a copy of an existing game, a Minecraft data pack, a language that only you are going to use. And eventually it will turn into something useful that everyone can benefit from.